Today's notes are called more ionic compounds, which are going to be compounds that all contain polyatomic ions. And this is still target 4.2 because we're still going to discuss ionic compounds. But before we move to the new types of compounds, let's review from our notes from the last class. So in our last class, we discussed things like NABR. In order to name this, we'd look at our periodic table and we would see that Na is sodium. Then we always want to ask ourselves, is sodium a transition metal? And since it's an alkali metal, it's not, so we don't need a Roman numeral. So then we just get to look at what Br is, and Br is bromide. And remember, these always end in IDE. Okay, let's look at number 2. We have Ca. Take a look at your periodic table. That is calcium. And we have to ask ourselves, is calcium a transition metal? And since it's not, we don't need a Roman numeral. So then we can go and look at P, which is phosphorus, but we changed the ending to phosphide. Okay, last but not least, we'll look at Cu. Cu on the periodic table is copper. And copper is a transition metal, so we'll need a Roman numeral. So I like to put the parentheses and then come back to that. And S is sulfur, so we change it to sulfide. So now for the Roman numeral. So remember, to determine a Roman numeral, we can create a little equation for ourselves. So we could think that the subscript times the charge, this would be for our cation, plus the subscript times the charge for our anion. This is always going to add up to 0 because an ionic compound, we have our charges balance out. So if we're trying to take a look at this one, we could say the subscript on our copper is 1, and we're trying to figure out what the charge of it is. We could call that X, plus the subscript on the sulfur is 1, times its charge, and if we look at the periodic table, that's -2, and that's going to equal 0. So then we solve that algebra, and we think 1x minus 2 equals 0. So 1x equals 2. So x equals 2. And that would be the charge on the copper. So I could fill in a Roman numeral 2. Now, if you're not someone who likes the algebra way, you just like thinking about it, we can do it a little bit simpler. We could look at sulfur. Sulfur, whenever it's sulfide, has a charge of -2. And since there's only one of them, that's the total negative. So then the total positive must be +2. And since we only have one copper there, that would be the charge on the copper 2. So either way you think about it, you're going to arrive at the same answer of copper has a charge of 2. So a Roman numeral 2. All right, now let's try writing a formula. So if I take a look, I have barium. When I find barium on the periodic table, it's element number 56. So it is Ba, and because it's an alkaline earth metal and it's in group 2, it has a charge of +2. Chloride, that's Cl, and because chloride is element number 17 and it's a halogen in group 7, it would have a charge of -1. So since those are unbalanced, we need to balance those charges. And in order to have them balanced, I would need 2 chlorines to balance out that +2 charge on barium. So my formula would be BaCl2. All right, the next one, cobalt. Cobalt is element number 27, and it has a symbol of Co, and it's a transition metal, which is why that Roman numeral is there, because that Roman numeral is telling us the charge, and the charge is +2. Then oxide comes from oxygen, so it's O. And oxygen, when it's oxide, it has a charge of -2. So in this case, our +2 and our -2 balance each other out to get that charge of 0. So we can just write the formula as COO, no subscripts necessary. Okay, so that's a review from last class. So let's talk a little bit before we start the notes for today. Let's just talk, what is a polyatomic ion? So a polyatomic ion, you can always find them on the back of your periodic table. And there's this big list, which is bigger than the list that you have to memorize. But this will always be there for you on tests and quizzes, except for your polyatomic ion quiz where you had to have them memorized. And so we're going to use this to do our compounds today. Now, what is a polyatomic ion? Poly means many, and atoms, many atoms, and an ion is something with a charge. So what a polyatomic ion is, it's a group of many covalently bonded nonmetals that act together like a single ion. So all of our compounds today are going to have more than 2 elements because they contain this polyatomic ion. So let's just get into how we do this and see. So first we're going to name a compound today. So in order to name an ionic compound with a polyatomic ion, it's going to sound very familiar to what we did in our notes the last class. First, we write the name of the cation. And again, we always want to ask ourselves, is that cation a transition metal? And if it is, then you need a Roman numeral. And then now, instead of worrying about what the name of the anion is by looking at the periodic table, we'll look at the list of polyatomic ions on the back of our periodic table and just write the name of that. And what's important to note is that we are not going to change the ending. So if you look at the list on the back, some of them end in "ide," like hydroxide. Some of them end in "ate," like acetate. And some of them end in "ite," like nitrite. And we're going to leave whatever ending it is. We're just going to write exactly what the polyatomic ion is called. So let's take a look at some examples. So we'll start by looking at what Na is. Na, element 11 on the periodic table, is sodium. And always ask yourself, is sodium a transition metal? It's not, so we don't need a Roman numeral. So then we just look at the rest of it. So we already used this sodium part. So now we'll look at the second part. So what we want to find on the back of our periodic table for our polyatomic ions is what is NO3. And you can see NO3 is right here, and it is called nitrate. So that's the name of this compound. NaNO3 is called sodium nitrate. Okay, let's try another example. So we have Ba on our periodic table. We can find it. That's barium. And as always, we'll ask ourselves, is that a transition metal? And since it's not, we don't need a Roman numeral. So then we want to look at our list, and we're looking for this OH. If we take a look, we can find this OH is right there, and that is called hydroxide. So this compound is called barium hydroxide. Okay, next example. Cu is copper. And so we can ask ourselves, is copper a transition metal? And it is, so we're going to need a Roman numeral. But let's go ahead and figure out what our polyatomic ion is. So our polyatomic ion is SO4. And SO4 is right here, and that is called sulfate. And again, we're not changing the ending, so we just write sulfate. And now we need to figure out that Roman numeral. So let's take a look. We've got CuSO4. And if we take a look at this SO4, it has a charge of -2. So if we go back to our equation from the beginning, then we would want to take a look at the subscript on the copper. The subscript is a 1 because there's not a subscript there. And then we'd try to figure out what the charge is on copper. And we're going to add to that the subscript on the sulfur, the subscript on the sulfate. Now this is a little bit different than we've done before because I'm with you. There's a subscript 4 there. But that 4 is what makes sulfate sulfate. There is not an extra subscript on there. In order to have an extra subscript, we would need parentheses and a number out here. We don't have that, so there's actually only one sulfate there. And if you're a little confused by that, once we write the formulas, that might make a little bit more sense. So we have one sulfate, and now we want to multiply times the charge, which is -2, and that's going to add up to 0. So we have x minus 2 equals 0. So x equals 2. So our charge on our copper is 2, so we'd put Roman numeral 2 there. Again, we're going to do lots of examples with Roman numerals and our polyatomics, so hold on tight if you're a little confused about that after. Let's go to another example. So here we have Mg. Mg is magnesium. And we want to ask ourselves, is magnesium a transition metal? And it's not, so we don't need to worry about Roman numerals. So we can just go straight to what is this PO4? All right, and this PO4, if we take a look at our list, PO4 is called phosphate. And since magnesium wasn't a transition metal, we don't really care about the extra subscripts there. Those will make more sense once we write our formulas here in the next section. So let's try. How do we write a formula for a compound that contains a polyatomic ion? So in order to write the formula, we'd write the symbol and the charge of the cation. Again, this should sound very familiar from the other ionic compounds that we did. Then we're going to write the formula and charge, but it's a polyatomic ion. And just like before, if the charges aren't balanced, we want to balance the charges and write them as subscripts. That way our net charge is 0, right? They balance out. Think about the Lego activity, how we wanted that perfect rectangle. And here's the extra little bit. If we want to put more than one polyatomic ion, we need parentheses. And we're going to write the subscript outside the parentheses. And then we'll always rewrite a formula with subscripts, but with no charges. Let's try our first example here. So our first one is lithium. Lithium on the periodic table is element number 3. It has a symbol of Li. And because it's an alkali metal, it has a charge of +1. So now instead of looking for the next thing on the front of the periodic table, we'll flip over to the back at our polyatomic ion list and find cyanide. So cyanide is right here, and it has a formula of Cn -1. So when we write our formula, we want to balance our charges, but a +1 and a -1 are nice and balanced. So we don't need to add any extra subscripts. It's already balanced, so we just rewrite it as LiCN. And this is very important about the capital and the lowercase, right? Li is lithium, capital L, lowercase I, and then cyanide is capital C, capital N, because it contains a carbon and a nitrogen. So just make sure you have the right things capital and lowercase. Okay, let's take a look at the second example. So barium, if we find it on the periodic table, it's Ba, and because it's an alkaline earth metal, it has a charge of +2. It's in group 2. And now we can find chlorate on our polyatomic ion list. Chlorate is right here, and it has a formula of ClO3 -1. So in this case, it's not balanced. We have 2 positive charges and only 1 negative charge. So what we need is 2 chlorates. So in order to write that, we'll write Ba, and we don't write the subscript 1, and then we'll write ClO3. But before we put that subscript 2 on it, we need to put parentheses around the polyatomic ion and the 2 outside the parentheses. This is so we communicate that we need 2 chlorates. If I didn't have the parentheses there, it would look like BaClO3, and then if I put a 2 there, that looks like I have 32 oxygens, and that's not what I want. I want to say, with parentheses, I have 2 of the polyatomic ion chlorate. So that's why we need our parentheses. So anytime we add an extra subscript to balance our charges, we want to put parentheses around that polyatomic ion. Okay, let's take a look at the next example. So the next example, we have aluminum. Aluminum is Al with a charge of positive 3. And if we find sulfate, sulfate is SO4 minus 2. And here's a case where the charges don't balance, and I like to think of it as like thinking of the lowest common multiple. So I'm going to get to like positive 6 and minus 6. So in order to do that, I would need 2 aluminums and 3 sulfates. And again, before I put the subscript 3 on the sulfate, I'm going to put parentheses around the sulfate and a 3 after. That way, I can see I have 3 sulfates and not 43 oxygens. Let's try 2 more. We have calcium, that is Ca plus 2. And we have phosphate on our list, that's PO4 minus 3. So the same charges as last time, but they're flip-flopped, right? So I'm looking for that charge of plus 6 and minus 6 in order to balance them out. So in order to get that this time, I would need 3 calciums and 2 phosphates. So I would do parentheses PO4 and the 2 outside the parentheses. Okay, on the next one, ammonium. This was on a test or a quiz. I would get a lot of questions. Mrs. Grezik, I can't find ammonium anywhere. That's because ammonium is our one polyatomic ion that has a positive charge. So it's our one cation. So ammonium is a polyatomic ion. So it's NH4 plus 1. And then oxide. Since we're doing polyatomic ions, you're going to look all over the back of this list and say, oxide's not a polyatomic ion. And your hint is that it ends in IDE. And that's because this is just oxygen with a charge of minus 2. And again, how do I know that it's just oxygen? 1, it ends in IDE. And 2, if I'm looking at this list of polyatomic ions on the back, I don't see it anywhere. So ammonium has a charge of only positive 1, and oxide is minus 2. So in order to balance out the charges, I need 2 ammoniums. So I'm going to write ammonium, parentheses, and a subscript 2 before I write my oxygen. And that's the end of the notes. Good luck on the work.